Hello and welcome to another video on congruence, and in this video we're going to look at what information we need in order to verify that two triangles are congruent. So first of all, we're just going to think about the three side lengths. If I were to draw another triangle with exactly the same three side lengths, do you know for sure that those two triangles are congruent? Okay, so let's give this a go. Let's first of all focus on this side length here, and I'm going to draw this in red. So I'm going to measure this side length and I'm going to draw it over here. So it looks like it's about 3.7 centimeters. So I'm going to draw another 3.7 centimeter line over here, and notice how it's in a completely different orientation to this one because I'm trying to draw a different triangle. And now I'm going to focus on this length, which I'm going to draw in blue. And it looks like this length is 5.8 centimeters. So I'm going to draw a 5.8 centimeter line up to here. And finally, I'm going to draw in this line here, which I'm going to do in green. And this green line is 6.2 centimeters. And this last line I'm going to connect from this red point here. So I'm going to draw a 6.2 centimeter line in here. So you can now see that I've drawn exactly the same three lines over here, but notice the obvious thing is we don't have a triangle. So in order to create a triangle, I'm going to need to connect this point here to this point here. And how am I going to do that? Well, I'm going to have to rotate this blue line inwards, and I'm going to have to rotate this green line inwards until they cross each other, or until they connect to each other to form a triangle. So let's do that. So first let's rotate this blue length inwards, and now let's do the same to the green line. And notice there's only one point where they both cross, and that is this point here. So what I can do now is I can just shift my blue length. So I'm going to draw my blue line from here to here, and I'm going to draw my green line from here to here. And I know that this is 5.8 centimeters because I've just rotated the line, and I know this is 6.2 centimeters because I've also just rotated this line inwards. And now we've constructed a triangle with exactly the same three measurements, and this triangle here is exactly the same as this triangle. They are congruent. They are exactly the same shape and size. The only thing that's changed is it's been flipped over and it's been rotated. So if we were to flip this triangle and rotate it sort of clockwise, we would be able to put it on top of this triangle here. So if we're told that two different triangles have exactly the same measurements for all three side lengths, then we know for sure that those two triangles are congruent. There is only one way of putting together those three side lengths to form a triangle. And hopefully I demonstrated that quite clearly with my diagram here. So we started off with the same side lengths but in a different orientation, and notice we didn't construct a triangle. The only way of making our shape into a triangle was for the three side lengths to be in the exact same orientation as our original triangle. So if we know that two triangles have the same three side lengths, so we could write side, 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 or just SSS for short, then we know that these two triangles are congruent, and we call that the SSS axiom. And if you're just unsure of what the word axiom means, it's just another way of saying that it makes logical sense without proof. So this is the side, side, side axiom. And in future videos, we're going to look at different axioms which we can use to show that two triangles are congruent. And they all involve a mixture of side lengths and angles. So hopefully you enjoyed that, and hopefully I will see you in the next video. Take care.